Okay, I'm recording this for like the 5th time now. Oops, I'm so unorganized that I forgot to change this. Okay, let's make it 4,000 so I can actually write. Okay. Whoa. Okay, there we go. So I'm a bit sick, as you may be able to hear. I've done this 4 times now. I screwed up the first 3. I had a good one on the 4th one, and then the audio didn't record. So I'm kind of pissed. But let's just get through it. Okay. So I'm sick. Hopefully that'll change. I have a test coming up, so there probably won't be that many for a while of these, but it probably won't matter. And then, okay, that's that. Something I noticed is that they're going to put some new stuff on the 2019-2020 exam. And by new, a lot of it's actually old stuff. So there's something called enumerated data types. And you don't need to worry about what this is until we get into object-oriented stuff. And it's not that hard. You just have to know a bit more. Something else they added is there's types of sorts where like you put numbers. You have like something that stores a bunch of numbers and you put them in increasing order. And they used to have bubble. I don't know about radix. This actually sounds familiar, but they used to have bubble and then they removed it. Maybe only for last year. But I think they added it back because it was just too easy with only these 4. And then they also added lambda expressions, which I've heard of ones in C++. But they added that for some reason. But I noticed that it's not added here anywhere, so I don't think we have to worry about it until we get into really weird questions. But I could see lambda on like some of these earlier ones. I don't know. I'll make a separate video on that because I actually have to read up on that. Okay, so today we're going over question 4, which is string class methods. So we went over what a string is in, I think, the last 2 videos. So if we make a variable that is type string, and let's say it's A, and we want it to store A, B, C, D, E, F, we would do this. A, B, C, D, E, F. And now this is stored in here. Something that I didn't tell you is that this string data type here is really powerful compared to something like int or double, which literally only holds a value. You can think of like this or this capital letter kind of hints at that, this capital S. But basically, this A can do a lot more than just store something. Now, what do I mean by that? I'll give an example. So let's say that we do system.out dot println A. Okay. This is just going to print out, the statement. Oops, sorry. Println A. Ooh, I'm screwing up. Okay, like this. And then if we run this, we'll see that, oh, okay, I ran it twice. That's okay. We see that it just does print it out. But what we can do is use something called an access modifier. And that's literally just a period, similar to in system.out.println, how we have these dots. And what this allows you to do, you can think of it for right now as like you have commands that are built into A that kind of, they don't modify what's stored inside of A, but it will return something with like a change in A, but you're not actually changing A. That's something important to know. So what I mean by that is, let's do A.to uppercase is a command, and you still have to put parentheses, but you don't have to put anything inside these parentheses. Now, what do you think this does? Well, it's quite obvious, probably, hopefully, it changes all the letters to be capital. Okay. Now what you'll notice then is on the next line, oops, sorry, if we do the same thing but we get rid of the 2 uppercase, we'll see that the A itself is not changed. What is happening, you could think of it, is that when we have A.2 uppercase, what replaces A.2 uppercase is taking this string, maybe creating a copy of it, and then changing it from there. So A, B, C, D, E, F. So then you change it there, and then this is what replaces this right here. But the actual string here, A equals this, is not going to change. So similarly, there's something called A.2 lowercase. And by the way, the reason why I just say A, it's just because I made the variable here. This could be, A could be anything that you type, or most things. There's some invalid things that you can't make. But basically, if I do, like, let's make this capital A, B, C, D, E, F, and then we change this from upper to lower, and then we run the program. Now let's see, it's the opposite. So we're changing it to lowercase, whereas A is actually uppercase. Okay. Something else, just to comment, you could technically put something like A.2 lowercase on its own line, like this, and it won't have an error. But when you print it, or when you run the program, it's not going to do anything. Like, here, I'll do this instead. So, like, it'll print out A right here, and it will do this, as in it will, like, basically the lowercase version of A will happen right here, but you're not giving any command from there, so it just kind of drops it, because there's nothing really to do with A.2 lowercase on its own. Now what you could do is maybe set that equal to another string variable, so we could do B equals this, and let's just make like C, like that. And now we can do system.out.println B. So I don't know where X came from. That's weird. So now I'll do this. So I'll change that C to a lowercase. Okay. Now you may ask, okay, how many of these little weird commands do we have to know? Well, if you look on the first page of your exam this year, you'll see this. And it's the standard classes and interfaces. Actually, this may be from last year. They're like updating stuff right now. So I'm not entirely sure. But it's going to look something very similar to this. And there's a lot of information. The stuff on the right side here, you don't have to worry about until like region and state. And you're not going to have to like know everything here. There's like specific things that as you get better, you'll learn like what you need to look at. So like one thing is you'll probably look at like what it implements, for example. Or if something says extends, yeah, like extends, you're going to want to look for that. But that's really it. What we're going to be focusing on is these right here. So this left-hand side, the lang package, okay, versus the utility package. The lang package is more for your invitational questions, okay? So we're going to be looking at these, most of them except these bottom three, because they involve something called irregular expressions, which is its own video, because that's a lot. But we've already tackled these two right here, string to lowercase, string to uppercase. So let's just, honestly, we could just go up from there. This works actually really well if we just go up. So I'm going to rehash that A is equal to A, B, C, D, E, F. Well, the way this string actually works is it's called an array of characters, okay, where a character can be represented with single quotes instead of double quotes, which just means that you're only storing one letter. So like there's another variable called char or char. I just call it, what do I call it? I think I call it char. Char, let's not do A. Let's do char C is equal to like maybe D. This is valid, okay? And if you do char C is equal to, with the double quotes, even though it's only one letter, this quotes is saying that you're trying to make a string variable. So this is not valid, okay? And similarly, this is also not valid, DE, because you can only store one letter inside a char, okay? So how it works is really you just are stringing together a bunch of chars, and that's what your actual string variable is. That'll make more sense later. But something, a result of this is that each letter here is represented by a number, and it's called an index. And the index just means that for each number in your string, counting from 0 and then up to how many letters you have, so we have 5 in this case, or we have 6 total, so the ending number is 5 because we start at 0. And the reason we start at 0 is just it's easier to make algorithms when we start at 0, just from experience, is that each like index here or address you can kind of think of corresponds to a letter. So 1 corresponds to B, 2 corresponds to C, the first letter, which is A, corresponds to 0, stuff like that. So we can use this with some of these commands. So I always mix these two up because they're like the opposites of each other. Okay, so if we do A dot index of, you can put a letter or a string inside of here, okay? And it will return that's like the thing where like whatever the result is kind of replaces wherever you put this, right? It will return the index where this C is located at, which is 2. And a little bit more is that it'll return the first index. So if we have like the word A, B, C, 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 and then we do index of C, let's say A is equal to this instead, it will return 0 for A, 1 for 2, and, I'm just counting. 0 is A, 1 is B, 2 is C. Oh, that's the letter we're looking for. Okay, so it'll return a value of 2. And it's the same thing in this case, because like A is 0, B is 1, and C is 2. So if we do A dot index of character C, and then we run the program, it will print out 2, which is kind of cool. Okay, something to note is that this is case sensitive, which means if we put a capital C right here, A dot index of will not will not be 2 because it's looking for a lowercase c. So then you're asking, okay, wait, what is it actually going to return? Because we see that lowercase c is not in this string of A. Okay, so what's going to be printed out? Take your guesses. It's -1. Now, why the heck is it -1? I thought we started counting at 0. And we do. And what the -1 says is we're telling the user who's like writing this code that like, hey, this letter you're looking for, it ain't in here. Okay, do what you want with that information. Okay, probably something's wrong or something. Now, what's interesting is even though you can, one letter can fudge, I don't know what I'm trying to say. Basically, instead of putting C with the quotes or with the apostrophes, you could also put them with quotes. And this is now a string, remember, because double or like quotes means that it's a string. And if we run this, it will print out, it's going to print out -1. But if we change this back to a lowercase c, now it's going to print out 2. Okay. Now, something's interesting is that you can combine them. So what we can do is A dot to lowercase. Oh, I didn't mean to change this one. Sorry. C. So we can do A dot to lowercase dot index of. Oh, shoot. Sorry. Remember to put your parenthesis. Okay. Dot index of. Okay. So if we do AB and then we change this to like maybe a capital C, normally, as we saw, this would return -1. But what's going to happen is you start from the left and then you go to the right. So what's going to happen is A dot to lowercase is going to replace whatever here. So we know that this is going to be like A, B, C, D, F. And now it's going to look inside of this new string that you've created essentially, and it's going to look for an index of C, of lowercase c, which is right here. And actually, I think you can technically do this. Hold on. Maybe. Yeah, you can actually do this. You can actually put a string right here, dot index of, and this will work, even though it looks very weird. Okay? But this works, okay? Similarly, you can put more than one letter. So we could do CDE like this, and it will look for the exact phrase CDE. Now, so if we run this, it will say 2. So what it will do, let me write this again, is it will look, so we put in CDE, we're looking for CDE, what is it, index of CDE, right? Like this. It will look for the exact phrase, so it'll start here and it'll go like over here, right? It's like ABC is not CDE, BCD is not CDE. Oh, CDE is CDE. And what it will do is it will return the number of the first index where this sort of match occurs. Okay, so 0, 1, 2, so it's going to return the number 2. Okay. I feel like I'm missing something, but I don't think I am. Oh, okay, so like what if instead this is CED? It's the same letters, it's just kind of swapped around. Is it going to return the same thing? Nope, it has to be the exact match. Okay. So there's if we look at what they're called methods technically. Ooh, wrong one. This one. Okay. So technically these are called methods, but we could call them like commands right now because that's probably makes more sense on what we're doing. You can see that we're actually missing 2 for index of. Also, I kind of skipped char app, but that one's really easy. We'll go over that next. Actually, no. Wait, did I say that? I feel like I have said char app, but maybe I haven't. That may have been from yesterday. So we can see that there's 4 index of methods here. Okay, we got the string. So this is like saying what type of data you're putting in inside the parenthesis. So string str, this is like saying that basically it's going to accept some sort of whatever data you put in, and if it's a string, it's going to do this method. So when we put like C with quotes around it, it's going to go to this method, whereas when I put a C with like apostrophes around it, it's going to go to this char method. And actually you see it's int here, which is technically the same thing as a char. A char is a type of integer, but an integer is not a type of char. Okay, I'll explain. This will make more sense later whenever we get to something called compare to. I'll talk about more about what this is, because that's probably really confusing. But we see that there's two more here, and it says from index. So we can actually put more than one, like, put sort of thing here. Kind of what we saw with system.out.printf. And you could separate what's called your parameters, or the data you put inside your parenthesis, using a comma. Okay, so we can also do index of C. Okay, so C, either this or like with a string. Okay, and then we can say we're going to start at a certain place inside our string. So let's say we start at the number 1. Okay, this means we're going to start right here at B, because B has the index 1, and we're going to start counting from here. So we're going to get B, and then now we see C is at the index 2. So even if you start counting at a different place, that doesn't change the index of the character. That's just gonna, it's just gonna start counting at a different place. Now, why is this significant? Well, what if you started counting at an index of 3, where D is? Okay, so we replace this 1 with a 3. Well, now we see that we're gonna start here at D, and we're just gonna go to the right. And we see that C is in here, even though it's like right behind it. So what we see, is if we do index of like C, for example, and then we start at an index of 1, so our starting index is 1, where we start counting, we'll output 2. But if we start past the C character, then we'll see that's a -1. So what this is nifty about is we can get, like, if we have 2 C's here, and normally we just put index of, it's going to return the first instance of it, right? So it's going to do 2, because 0 and 2, even though there's a second one here. But if we start counting at 3, well, now it's going to start counting at D, and it's going to look for a C to the right. So now we're going to see that it's 6, because A is 0, B is 1, 2, 3, 4, 5, 6, and C is at 6. Okay. So there's another method which you could think of as the inverse, and it's called char@, or char@. So if I do a.char@ and then 2, this will return the letter that represents that index, which is really easy. So like this would just print out C, because like if it'll literally just like, okay, here's the index of 2. What letter's there? Oh, it's C. Okay, cool. Like I could just like real quick a.char@ 2, like this. Oop. Okay. It's not bad. Now what we could do, just as like more practice, is a.2 uppercase, and then dot, and then this will be a capital C, because you go from left to right, so it's going to turn the whole thing to an uppercase, and then it's going to look for the string there. Okay. So what do we have left? I think that's a lot of it. So we've done from here, or sorry, not split. We've done from here up to here. So we're going to do substring. And substring is also really easy. So if we have A, B, C, D, E, F, and this is equal to A is storing this, right? What substring does is it takes like a section of the string that you're creating. So like we could do a.substring from 1 to 4, for example, okay? And what this will do is, this is called, the 1 will be what's called inclusive, and the 4 will be what's called exclusive when it comes to the indexes. So let me write out the indexes again real quick. 3, 4, 5. And the way you could think of this is basically find the first number here, the 1, draw a line to the left, find the 4 number here, that's 4, E's there, draw a line to the left. So you just draw a line, okay? And you'll see that there's like these some letters in between your lines. This is the substring. So we'll see that it's B, C, D. So if we do substring B, 1 to 4, okay, it will print out B, C, D, because, I'm running out of room, D, E, F, because we're going to include the B, which is at index 1, and even though we put a 4 here for a second one, we're going to exclude the other one. So it's inclusive, exclusive. So just draw a line to the left for both of them, and that will take away any uncertainty with anything. Like, here's a good one, okay? What if we do, so we have A, B, C, D, E, F. What happens if we output, what happens if we do, you know, substring of 1 to 1? Okay, started this one, that's at B, draw a line to the left. What's our second number? 1, draw a line to the left. Boom, nothing. So we shouldn't have anything. 1, 1. Something I'm curious about is what happens if your starting index is larger than your second one. So like you do 2, 1, because that should kind of break it, right? Because A, B, C, D, E, F, you start at 0, 1, 2, C, draw a line to the left, then you find 1. I don't think it's going to be B. I think that is a case that would break this. It's probably going to be like an illegal parameter exception, or illegal string index out of bounds exception. Yeah, whatever. Doesn't really matter. String index out of range, -1. Ignore it. Okay. Just know that you can't do this, okay? The first number has to be equal to or less than the second number. Okay. So there's one more thing. There's another substring. And it could just be, let me write A, B, C, D, E, F. Okay, and now we do substring of 1. Okay. This is something else you could do. Or shoot, not equals, a dot substring. What this will mean is you start at B, or you start at whatever the index of like whatever you put in here is. So for this example, it's 1, draw a line to the left, and it's just saying starting from this line you drew all the way to the end of the string is your substring. So it's just gonna be B, C, D, E, F. Okay? So if we do like, we can put one number here, and voila, B, C, D, E, F. And then C, because I forgot I put a C here. My bad. Okay. And that's that. And begin and end. Okay. There's another one called length. And this is literally just how many characters are in your string. B, C, D, E, F. So if we have this, 1, 2, 3, 4, 5, 6. We have 6 characters. So even though we start counting at 0, the length is still 6. Okay. So if we do a dot length, and then we just run it, we'll see that it's 6. 7. Sorry, there's a C here, I forgot. Okay, now this is our string. Now what happens if you make it empty? It returns 0. What happens if you don't put anything at all? You could technically do this where you say that you're making A, but you're not storing anything in it. Then you have what's called it wouldn't be a no pointer exception. Or would it? It won't let you. It'll do a compile error is what it's called. So it's not going to be a runtime error. Runtime's errors happen because of logical stuff. It's stuff that the compiler can easily check. So actually, wait, can I do this? Equals null. Well, when you do a string A and you don't put anything inside of it, the value of null, which represents that there's no data, is like already stored inside of A, because null just means that there is no data inside of A. So if I say string A is equal to null, that's the same thing as string A. But I think no pointer access is what it's called. The variable A can only be null at this location. So there's something called the suppress warning where you're like, hey, chill, okay, I know what I'm doing. It's not going to cause an error, but then when you run, it's going to crash. No pointer exception. Yeah, there it is. Okay, sorry, you don't need to know a lot of that. I got a side tangent. Where were we on? We were talking about length. I don't know how I got there. Okay, we have 2 more. Equals. So how equals works is it basically compares if 2 strings are the same. So A dot equals B. Let's say that we say B is equal to A, B, C, D, E, F. If we do A dot equals B, this would be true. And then if we remove one of these letters, now this is going to be false. And maybe if we make one capital, this is going to be false, you know? It's like that. So let me do that. A is equal to A, B, C, D, E, F. String B is equal to A, B, C, D, E, F. A dot equals B, and you could do like B dot equals A. There's nothing saying you can't do that. Forgot my semicolons. Let me get rid of this. Not the class name, the suppress header. Okay. And we'll see it's true. Oh, sorry. That's not the console. And if I change this to like a capital D and then run it, boom, false. Okay, cool. That's that. I think that's... I feel like I'm missing something for equals, but I don't think I am. Also, oh, okay. This may be important. You can do a dot equals null, and this will run. And it will just output false because obviously this is something. So null doesn't always mean you'll have an error. So you can do a dot equals null. And the technical reason, we won't understand it until way later on. But it's because it doesn't only take a string, it takes just any object. Which is like, what's an object? It's like, well, it's useful. Okay, we use it a lot, but... And you're technically using them right now, you just don't know it. But that's okay. Okay, last one, compare to. So compare to... Wow, I'm like running out of space. Let's go up here. Okay, so compare to is an interesting method, and what it does is the rule is okay. If so, we're gonna be comparing two things. Okay, when you do a dot compare to b, if you have two strings, you're gonna be comparing a versus b, right? And there's three things that can happen. It will either return, or the value here of compared to will either be less than 0, and this happens if a is greater than or less than b, less than b, less than b. Okay, it's equal to 0 if a equals b. Actually, this, I don't have to put that quotes there. Okay, and then it's greater. Actually, no, I kind of do. And it's greater than 0 if a is greater than b. Now you may ask, why am I putting these quotes here? Well, like, if I have two strings, like I do in this case, two words, what means one is less than the other? And the way we define it, just by convenience, is if you are alphabetically above another word, you are Whoops. Okay. Hopefully I'm back. I hope my microphone has been in for most of the time. So you can do lowercase h minus uppercase h, and this will actually return a value of 32. Something to note is that even though your uppercase I kind of think of as bigger, they're actually technically the smaller number. So just remember that so you don't make a silly mistake. So now we can dive into how compare to works. The algorithm for compare to is it will check each string at each corresponding index, okay? And when it finds the first index where there is a difference, it will return the index of A minus the character at the index, the character at that difference at A minus the character at the index of B. So A is equal to A, B is equal to B, C is not equal to H. Now, what is the difference here? Well, now it's going to be C minus H, okay? And let's think about it. You can either think, okay, lowercase a is 92. Wait, is it 93 or 92? It's 97, okay? Ooh, okay, 97, okay? And then lowercase h is going to be, D, E, F, G, H. Okay, don't do this. Okay, don't do this. Basically, just think of the difference between them. Okay, so if we start at C, what do we got? D, E, F, H. Okay, so what's the difference here? We got 1, 2, 3, 4. So this should output 4. If we do A dot compared to B. So we do C here, A, B, C, D, and then we do H here. So this should output 4. Oh, okay. Sorry, silly mistake. Okay, remember, H is going to be a larger number than C. So if we do C minus H, this should be negative, okay? And also, I forgot the letter G. So it's C, okay, D1, 2 is E, 3 is F, 4 is G, 5 is H, okay? There should be negative 5. My bad. Okay, the reason why I'm not good at this is because we don't use compare to in this way where we're looking for the exact number. Normally we just check that it's a less than something, okay? Or greater than something. And you don't even do that yourself, really. Okay, but basically this is what you need to know about this method is it's going to be the first character where they differ, and then it's going to be subtracting their ASCII values. Now if they're the same, then it's just going to return 0. And I think that's it. I think that's all we need to know. Something here. I don't know if they're going to ask about something like this yet, but just know. Oh, no. By the way, so, like, if you have an evil question where, like, the compare to is basically, like, capital D minus lowercase, like, h, okay? Well, we know from capital D to lowercase d is going to be 32. Well, actually, this would technically be negative 32, right? Because d is less than lowercase d, so it's going to be negative 32, okay? And now we can think of it, so we've went from negative, or capital D to lowercase d, and now we just need to go from lowercase d to lowercase h, okay? And now we can just do our ABCs, and then you just, like, you don't count d when you start, so you count the next letter, so, like, E, F, G, H. That's 4, so it should be negative 36. So if you have a nasty question like that, I wouldn't see that on like a district, maybe regional, actually definitely regional. That happened to me last one, and I couldn't remember the numbers because I was a dummy head. Sorry. DH, I think this would work. Negative 36. Okay, yeah, woo, we're going to state, guys. Other than that, the only thing I don't know if you need to know this right now, but if something here on the reference sheet has implements comparable, that literally just means it has the compare to method. It has to have it or else it couldn't exist in the first place. Like the code would not compile. So we can see actually here's the interface comparable, and I'll give you a hint if returns a value less than 0 if this is less than another object. For right now, we can just think of it as if this string is less than another string, but you can technically do this with other what are called objects, which you don't even know yet. But that's okay. So we see that integer has a comparable, okay, and that will literally just, that's actually a good one. Let's go over that. I think if you do like, can you do 4 dot compare to? You probably can't. Well, actually maybe you can. No, you can't. Okay. So you could kind of do the same thing with integers as you do with string. So you can literally type out capital I for integer rather than just like lowercase I, and then you could do 4 like this, and this is technically valid. And then we could do like b is equal to 7. Okay, and then I think if we do sys out a compared to b, this would be a minus, or 4 minus 7. Is that right? -3, -1. So I think how that would work then is that as long as a is less than b, it's going to return -1. If a is equal to b, it will return 0. And if a is greater than b, then it will return +1. So if I make this like 40,000, it's probably just 1. Yeah, okay. That's how that works. You don't need to know that for right now. We'll go over comparable on its own another day because that's its own whole thing. But we can see that basically all of these right here will have compare to methods. Double should work the same way as integer. And yeah, okay. Hopefully this is the last time I have to record this.